What if I told you that a country surrounded by enemies and covered 60% by desert has become the world's leading exporter of water technology, supplying solutions to over 40 nations facing water crises? It sounds impossible, right? Well, Israel actually did this, and the result, after 6 decades, has transformed not just their own survival, but inspired water revolutions from California to Cape Town, from Australia to South Africa. This is that incredible story of how salt water became liquid gold and how Israeli tech is now everywhere. Picture this. You're standing in the heart of the Negev desert, where rainfall averages just 200 millimeters per year. The temperature soars above 40 degrees Celsius. The soil is sandy, salty, and seemingly lifeless. For thousands of years, this was considered uninhabitable wasteland. Yet today, this same desert produces cherry tomatoes, bell peppers, and flowers that are exported to European supermarkets. The secret isn't magic. It's salt water transformed through revolutionary technology that defied every expert prediction. But to understand why Israel would attempt such an impossible feat, we need to go back to 1948. When Israel declared independence, the new nation faced an immediate crisis that threatened its very existence. Not just military enemies, but something even more fundamental: water. The numbers were absolutely staggering. Israel had just 1,800 cubic meters of renewable fresh water per person per year. The World Bank defines water scarcity as anything below 1,700 cubic meters. Israel was already below the crisis line before they even began building their nation. To make matters worse, 60% of their territory was desert, and the little fresh water they had was shared with hostile neighbors who could cut off supplies at any moment. For decades, Israel tried everything conventional wisdom suggested. They built reservoirs to capture the rare winter rains. They recycled every drop of wastewater, becoming world leaders in sewage treatment and reuse. They developed revolutionary drip irrigation that reduced agricultural water consumption by 50%. They even experimented with cloud seeding to increase rainfall. But none of this was enough. By the 1990s, Israel was consuming more water than nature replenished. Their underground aquifers were dropping dangerously low. The Sea of Galilee, their largest freshwater source, was shrinking year after year. Agricultural production was limited not by land or expertise, but by simple lack of water. The country that had made the desert bloom was running out of the resource that made it possible. Water economists warned that Israel faced a choice: dramatically reduce their population and agricultural output, or face ecological collapse within decades. Neither option was acceptable for a nation surrounded by enemies and committed to absorbing immigrants from around the world. That's when Israeli engineers proposed something that sounded both brilliant and insane. Why not use the Mediterranean Sea as their primary water source? The Mediterranean surrounds Israel's western border with virtually unlimited seawater. If they could just remove the salt, they'd have infinite fresh water. But every expert knew that desalination was prohibitively expensive, costing 3 to 4 times more than conventional water sources. The energy requirements were massive, the technology was unproven at scale, and the environmental concerns were enormous. Critics called it economic suicide and throwing good money into the sea. International water experts said Israel was wasting resources that should be spent on conservation and diplomacy. Major newspapers ran headlines like "Israel's billion-dollar bet on seawater" and "Desert Nation's desperate gamble." Even within Israel, the debate was fierce. Conservative water managers argued for stricter rationing and population limits. Environmental groups worried about the energy consumption and marine ecosystem impacts. Economists calculated that desalinated water would make Israeli agriculture uncompetitive in global markets. But Israeli leaders weren't ready to accept defeat. In the late 1990s, they made a decision that would change everything. They would build not just one desalination plant, but an entire network of facilities along their Mediterranean coast. The centerpiece would be a massive complex called Sorek, designed to be the largest and most efficient desalination plant in the world. The Sorek project was an engineering nightmare from the very beginning. The plant would need to process 627 million liters of seawater every single day, enough to fill 250 Olympic swimming pools. It would require revolutionary reverse osmosis technology operating at previously impossible scales. The facility would need to be built on Mediterranean coastal land, where real estate was extremely valuable and environmental regulations were strict. Construction began in 2010 with a budget of $400 million. But this wasn't just about building pipes and pumps. Israeli engineers were developing completely new approaches to desalination that would make the impossible economically viable. The breakthrough came through revolutionary membrane technology. Traditional desalination used energy-intensive thermal processes that boiled seawater to separate salt from fresh water. But Sorek would use advanced reverse osmosis, forcing seawater through specialized membranes under enormous pressure. The key innovation was developing membranes that could handle much higher pressures while using dramatically less energy. Israeli companies like IDE Technologies worked with international partners to create membrane systems that were 50% more efficient than anything previously built. They designed energy recovery systems that captured the pressure from brine discharge and recycled it back into the process. They developed pre-treatment systems that prevented membrane fouling and extended operating life. But the real revolution was in scale and automation. Sorek would operate with minimal human intervention, using advanced sensors and AI systems to optimize every aspect of the desalination process. The plant could automatically adjust to changing seawater conditions, energy prices, and water demand in real time. The construction phase faced enormous challenges. Mediterranean storms delayed equipment installation. Environmental protests required extensive mitigation measures. The complex membrane systems required precision engineering that pushed manufacturing limits. Workers had to install massive intake pipes extending 1.5 kilometers into the Mediterranean to ensure consistent water quality. Then came the economic pressure. As construction progressed, global commodity prices soared. Energy costs spiked due to Middle East conflicts. Critics pointed out that every delay and cost overrun proved their predictions about economic impossibility. By 2012, when construction was nearly complete, skepticism reached its peak. Water economists published papers showing that Sorek water would cost at least 0.70 per cubic meter, making it among the most expensive water on Earth. Agricultural experts warned that Israeli farmers couldn't compete using such costly irrigation. International observers predicted the plant would operate at massive losses and require permanent government subsidies. But when Sorek came online in 2013, something extraordinary happened. The plant didn't just work, it exceeded every optimistic projection. Instead of costing $0.70 per cubic meter, Sorek produced water at just $0.50 per cubic meter. This wasn't just competitive with traditional sources, it was actually cheaper than treating and transporting water from Israel's distant freshwater sources. The economies of scale, technological innovations, and operational efficiency had achieved what experts said was impossible. The water quality was remarkable too. Desalinated water from Sorek was actually purer than most natural freshwater sources. It required minimal additional treatment and could be delivered directly to homes and farms. The plant operated with 99.7% reliability, producing consistent output regardless of weather, political tensions, or natural disasters. But perhaps most importantly, Sorek liberated Israel from water scarcity constraints that had limited their development for decades. For the first time since independence, Israel had unlimited access to high-quality fresh water. They could expand agriculture, increase population, and develop water-intensive industries without depleting natural resources or depending on external sources. The agricultural transformation was breathtaking. Israeli farmers, now with unlimited irrigation access, developed the world's most productive desert agriculture. They perfected greenhouse systems that produced European-quality vegetables using 95% less water than traditional farming. They created export industries, selling fresh flowers and premium produce to markets thousands of kilometers away. The Negev desert, once considered worthless wasteland, became Israel's agricultural frontier. Vast greenhouse complexes emerged where nothing had grown for millennia. High-tech farms produced organic vegetables, exotic fruits, and even freshwater fish in the middle of the desert. Israeli agricultural exports soared from $1.2 billion to over $2.5 billion annually. The country that had struggled to feed its own population became a major agricultural exporter. Desert-grown Israeli produce appeared in supermarkets across Europe, Asia, and North America. But the real breakthrough was what happened next. The success of Sorek triggered a complete transformation of Israel's water economy. Instead of being water scarce, Israel became water abundant. They built 4 more major desalination plants along their coast. By 2023, desalination provided over 60% of Israel's domestic water supply. The environmental impact was remarkable too. By relying on desalination instead of overpumping aquifers, Israel's underground water levels began recovering for the first time in decades. The Sea of Galilee, which had been dropping dangerously low, stabilized and began refilling. Rivers that had dried up started flowing again. Israeli cities no longer faced water restrictions. Swimming pools, gardens, and water features became common even in desert towns. The country that once rationed every drop became known for abundant, high-quality water available 24/7 throughout the entire nation. But perhaps most impressive was how this transformation caught the attention of water-stressed regions worldwide. As news of Israel's success spread, delegations from drought-affected areas began visiting Sorek to understand how impossible had become profitable. What happened over the next decade exceeded every prediction about the global impact of Israeli water innovation. The technology perfected at Sorek became the foundation for water security revolutions on 5 continents. The first breakthrough came during Cape Town's Day Zero crisis in 2018. South Africa's premier city was literally running out of water, with municipal supplies projected to end within months. Traditional solutions, drilling more wells, building more dams, would take years to implement. But Israeli desalination technology could be deployed in months. IDE Technologies, the company behind Sorek, rapidly designed and built emergency desalination systems for Cape Town. Within 8 months, they had multiple plants producing 150 million litres daily of fresh water from the Atlantic Ocean. The crisis that threatened to make Cape Town the first major city to run completely dry was averted using Israeli technology perfected in the Negev desert. But Cape Town was just the beginning. California, facing its worst drought in recorded history, turned to Israeli innovations for salvation. The state invested $1.2 billion in desalination plants based on Sorek technology. The Carlsbad plant, using Israeli reverse osmosis systems, now provides water for 400,000 people, while operating at costs comparable to traditional sources. Australia, which had struggled with water scarcity for decades, embraced Israeli desalination on a continental scale. Major Australian cities including Sydney, Melbourne, and Perth built desalination facilities using technology refined at Sorek. Today, these plants provide backup water security for over 15 million Australians, ensuring that even severe droughts cannot threaten urban water supplies. The technology spread far beyond wealthy developed nations. Morocco built a massive desalination complex using Israeli technology to support economic development in previously water-limited regions. The plant provides water for both urban populations and agricultural expansion, enabling Morocco to develop export agriculture in areas that were previously too dry for farming. India, facing water crises affecting hundreds of millions of people, partnered with Israeli companies to build desalination facilities along both coasts. These plants now provide crucial water security for major cities including Chennai, which had faced complete water depletion in 2019. Chile, with its extensive Pacific coastline but arid interior, built a network of desalination plants based on Israeli technology. These facilities support both copper mining operations and agricultural development in the Atacama Desert, one of the driest places on Earth. Even oil-rich nations embraced Israeli water technology. Saudi Arabia, despite vast financial resources, found that Israeli desalination was more cost-effective than their previous thermal desalination systems. The kingdom invested billions in Israeli-designed reverse osmosis plants, dramatically reducing their energy consumption while increasing water production. The numbers became staggering. By 2024, over 40 countries were using Israeli desalination technology. These plants collectively produce more than 100 billion liters of fresh water daily from seawater, enough to supply the domestic needs of over 300 million people. The technology that critics once called economic suicide had become the foundation of water security for hundreds of millions of people worldwide. But the impact went far beyond just producing water. Israeli innovations revolutionized how the world thinks about water scarcity. Instead of accepting natural limitations, countries learned they could engineer their way to water abundance using the vast reserves of seawater that surround most populated areas. The economic transformation was remarkable. Countries that had limited development due to water scarcity could suddenly support population growth, industrial expansion, and agricultural development. Desert regions became viable for large-scale settlement and economic activity. Coastal nations gained strategic independence from upstream water sources controlled by potentially hostile neighbors. Environmental benefits emerged too. By providing alternative water sources, desalination reduced pressure on overexploited rivers, lakes, and aquifers. Ecosystems that had been damaged by excessive water extraction began recovering. Species that had been threatened by habitat loss due to water diversion found their environments stabilizing. The technology kept improving as deployment expanded. Israeli companies developed more efficient membranes, better energy recovery systems, and advanced automation that reduced operating costs even further. Plants built in 2024 produce water at 30% lower costs than early facilities like Sorek, making desalination competitive with conventional sources almost everywhere. International cooperation flourished around Israeli water technology. The country that had once been isolated and embargoed found itself an essential partner for water security. Trade relationships developed with nations that had previously had no diplomatic contact with Israel. Water expertise became a form of soft power that opened doors to broader cooperation. Training programs brought thousands of engineers and water managers to Israel to learn desalination technology. Israeli universities developed specialized courses for international students focused on water engineering and desert agriculture. Knowledge transfer accelerated innovation in water-stressed regions worldwide. The research and development ecosystem exploded. Israeli water technology companies expanded internationally, building local facilities and hiring local workers in dozens of countries. Joint ventures emerged between Israeli firms and international partners, spreading both technology and manufacturing capabilities globally. Investment poured into water innovation. Venture capital funds recognized Israeli water technology as a growth sector with enormous global market potential. Startup companies developed specialized solutions for water treatment, distribution, and management. The ecosystem that had emerged from desperation in the Negev became a globally competitive industry cluster. Perhaps most remarkably, the success created positive feedback loops that accelerated further innovation. As Israeli water technology proved successful internationally, investment in research and development increased. Universities expanded water engineering programs. Government support for water innovation grew. Private companies invested more in next-generation technologies. Today, Israel stands as proof that no natural limitation is permanent. The country that faced existential water crisis now exports water technology to over 40 nations. The desert that once threatened to limit their survival became the testing ground for innovations that provide water security to hundreds of millions of people worldwide. From the Mediterranean coast to the heart of the Negev, from Cape Town to California, Israeli technology has transformed how humanity approaches its most fundamental resource. Salt water, once considered a barrier to development, became the foundation of abundance. The transformation that began with desperate necessity in a small desert nation became a global revolution in water security. What started as Israel's survival strategy became humanity's blueprint for turning Earth's most abundant liquid resource into the foundation of sustainable development worldwide. And this is just the beginning. As climate change intensifies water stress globally, as populations grow in water-scarce regions, as traditional sources become unreliable, Israeli desalination technology offers a proven path forward. The salt water that covers 71% of our planet's surface represents virtually unlimited potential for freshwater production. The impossible became inevitable. Israeli tech really is everywhere, turning seawater into life, desert into oasis, scarcity into abundance. What other limitations do you think human ingenuity could transform into opportunities?